Hey, I'm Ben, project engineer here at ChopValue.
Hey, and I'm Sabrina, Director of Sustainability at ChopValue. Today, we're getting into something that we get asked about quite a bit, ChopValue's carbon footprint advantage.
We're looking to elaborate and explain how ChopValue's engineered material compares to the typical commercial standards, which are particle board, fiber board, and solid wood. For this exercise, we're going to be looking at solid maple as the solid wood example.
We're not just talking about the furniture that you see in a store, we're talking about the entire chain. So from where the raw material comes from, the energy it takes to make it usable, how far it travels, and also how long it lasts before it's thrown away or repurposed.
Let's begin by comparing the resources.
Let's start with particle board and fiber board. What are they usually made of?
Most particle boards and fiber boards are made of spruce. While particle board can include some recycled content, ranging from 30 to 90%, it remains mostly virgin timber. So I'd like to begin by explaining how we calculate the potential in carbon dioxide avoided or emitted before going deeper into each of the materials. Let's use the example of spruce. So wood from a spruce tree has a density of approximately 630 kilograms per cubic meter, and the chemical composition of wood being approximately 50% carbon, and the balance being oxygen, hydrogen, and a few other trace elements. So with this knowledge, we're able to calculate that 1 cubic meter of wood from a spruce tree can store 315 kilograms of carbon. And using the standardized greenhouse gas equivalency multiplier of 3.67, this translates to 1,156 kilograms of CO2.
So how does that compare to solid maple?
Solid maple is a little bit more dense than spruce, at 685 kilograms per cubic meter. Using the same greenhouse gas equivalency, a cubic meter of maple can store 1,257 kilograms of CO2.
How does that compare to ChopValue's material in terms of carbon storage?
So ChopValue's material density is about 1,000 kilograms per cubic meter. And with a carbon content of about 45% for bamboo, that means that every cubic meter stores about 458 kilograms of carbon, or 1,681 kilograms of CO2 equivalent.
And because we're using recycled materials, the carbon already in those chopsticks stays locked in for longer. So there's two additional factors that come into play when we're talking about resources, especially comparing ChopValue's engineered material. Firstly, when we harvest a tree, about 50% of that organic material is usable and ends up in a final product, which is a very inefficient use of resources. Secondly, harvesting trees disrupts the natural propagation of forests and affects the carbon storage potential.
If we add up the potential storage of carbon equivalency, as well as the storage provided by ChopValue's material, we sum up to a whopping 14,959 kilograms of CO2 emissions avoided. And these are emissions we're avoiding as a result of simply opting for a waste stream as opposed to using a virgin material. So how does our ChopValue engineered material compare?
Chopsticks that otherwise would have ended up in the landfill are collected from local restaurants that we partner with and transformed into high-performance material in our microfactories. The biggest win is that no trees are cut down for our products, and we call this urban harvesting. We're using resources already available in our cities, which minimizes the environmental impact and encourages better resource efficiency.
So every time we make a table, a wall panel, or insulation feature, that's one less product that required virgin timber.
Now let's talk about manufacturing. Walk us through the traditional process and how that compares to the ChopValue process.
So the three traditional materials, fiberboard, particle board, and solid wood, uses a combination of debarking, chipping, cooking, pressing, cutting, before finishing. So the advantage of ChopValue's manufacturing process is that we're utilizing a resource that's already been processed and is destined for the landfill. We're able to reprocess, remanufacture this waste stream into a final product in just 2 simple steps. Utilizing our manufacturing process, we're able to avoid 329 kilograms of CO2 equivalent. That's a 41% reduction in emissions at the manufacturing stage compared to commercial standards. So logistics is another big piece, where people are often surprised. What happens with conventional materials?
In a standardized, centralized supply chain, products travel a pretty long way. For example, let's say you have a forest in China where the tree is harvested and then travels about 1,000 kilometers to a manufacturer within China, then about 500 kilometers to a port in Shanghai, which is then another 10,000 kilometers by ship to a port in Vancouver, and then a truck to a supplier in Ontario, and then let's say finally another 50 kilometers to the end customer in Toronto. That's a pretty long distance. Whereas if you compare it to ChopValue's hyperlocal approach, we collect our raw materials from local restaurants. They then arrive at one of our local microfactories within the network, and the products are manufactured and are then distributed to customers within that same region. The good thing is that we're actually minimizing the entire distance of which our products travel.
Each of those steps utilize energy, often burning fossil fuels, emitting a very avoidable greenhouse gas. On average, for conventional materials, the logistics emissions work out to around 965 kilograms of CO2 per cubic meter. Our total transportation footprint is only about 575 kilograms of CO2. So that's roughly a 39% reduction, avoiding 362 kilograms of CO2 per cubic meter, and that's due to our hyperlocal approach.
Now let's talk about life cycles. How do the life cycles of commercial materials compare to the life cycle of ChopValue's material?
Fiberboard and particle board have just one life. They unfortunately can't be refinished, and at the end of their use are either burned or trashed, which releases the carbon they were previously storing. Solid wood and ChopValue's engineered material are different in that they can be resanded, refinished, or even repurposed. So when comparing the life cycle and the stored carbon in each material over its lifespan, standard commercial materials on average emit 2,259 kilograms of CO2, whereas ChopValue's material only emits 1,681 kilograms. Therefore, the total emissions avoided from choosing ChopValue's material over traditional commercial products sums up to 578 kilograms of CO2.
So that means our material can go through up to 3 full life cycles, about 39 years on average compared to 13 years for conventional materials. We're extending the life of the material beyond just one use.
Put it all together, the resources, manufacturing, logistics, and the life cycle, here's what we see. By choosing ChopValue's material, you can effectively prevent 16,228 kilograms of CO2 from being emitted.
And it's all because we're using a resource that already exists, processing it efficiently, keeping it local, and making sure it lasts.
Renewable resources are valuable, but waste streams are an even better starting point. They offer the greatest carbon savings while taking some pressure off of our planet's limited and dwindling resources.
And that's the carbon footprint advantage that we're building into every single product that leaves a ChopValue microfactory. If you want to learn more, please check out our Urban Impact and Sustainability Report, which has a lot more insights and data into the work that we just talked through. Thanks again for your time.
Bye.
Bye.